Welcome. In this video, we start about application of derivatives and we talk about monotony. So when we talk about monotonicity of a function, we don't necessarily mean that we're talking about the maximum and the minimum values of a function, but we're talking about the study of the behavior of a function in terms of whether the function is increasing or the function is decreasing. So monotony refers basically to these things, whether the function is increasing or the function is decreasing. But when the problem of maximum and minimum relates to monotony, it relates to monotony because the concept is clear. If some function is increasing and after some point this function decreases, means that you have reached the maximum point and then the function started decreasing because it could not pass to that point. And if the function is decreasing and after some time this function stops decreasing, then you have reached the bottommost part of that function, which means is the minimum value, the lowest value of that function. Hence, because of the study of the behavior of the function to know whether it is increasing or decreasing, we were able to find the limits of a function which are the extreme values of the function. The upper one will be the maximum and the lower one will be the minimum. So there are three propositions that are made for the study of monotony of a function, which is the behavior of a function. The first one says that if we have a function f of x which is differentiable between the interval of a to b, and we have a point x1 which is in the extreme in this interval, the derivative of this function at that particular point is going to be 0. So what basically tells us is that we have a function and then within that interval that was given to us, we'd have a point which is in the extreme, somewhere like here, but because we're talking about an x point, we take it in this side, which will be somewhere in the a and in the b. So if we have such point and the derivative of this function is made 0, then this point is giving us the maximum and minimum values of some given function. So if we make it 0, the derivative of that function at that point, we have the maximum or the extreme values of that function. That's why it's called now as extreme point. So it will be extreme because this thing is going to be true. So how it makes sense for us? It makes sense because if you try to draw a line here and another line here, you find that your function is just within this interval. It doesn't go beyond it. So we can conclude that this sounds to be right because the function does not go above this point and doesn't go below this point. So monotonicity in this point, what it tells us is that this function is decreasing. Within the given interval, the function is decreasing. Doesn't tell us whether the function is reaching its maximum or minimum, but it's just decreasing. And for the sake of this example, yes, the function started decreasing from this point, which means that if it started decreasing for some point, it means at that point where the function was, it was a maximum, and it started decreasing till this point. But after this point, we don't have any information because this interval does not concern for us the outer part. So the function is constantly decreasing. So within this range, the function is decreasing, and we found the maximum value where it started decreasing and the minimum value where it ended, it stopped decreasing. But this is not working for all the cases. Imagine that you have a function like this: f of x is equal to x raised to 3. So in this case, if you have to find the derivative of this same function, as we did, as the concept says that worked here, this would give us f dash of x is equal to 3x squared. And then now what we have to do is make it equal to 0, which is here. So our x in the end is going to be 0. So we have made the derivative of that function at a given point equals to 0. But the thing now is that this point that we have found here, this point 0, is neither maximum nor minimum. So we cannot conclude that this point here, which is again parallel to x-axis and actually coincide with the x-axis, this, if you make a line here, it will be the tangent of our graph. But it does not mean that this was extreme point of a function. Doesn't mean that this was a maximum nor a minimum. So there are some limitations when we use only this proposition. And to solve those kind of limitations, we have two more propositions. that says that if the derivative of that function is greater or equal than 0 for all the x belonging to this interval, then the function is increasing. So if this derivative is, if it's equal to 0, we have something called critical point. Critical point. So what is a critical point? Critical point is a point that the function is likely to get maximum or minimum. So when it is equal to 0, when the derivative of that function at a point within that interval gives us 0, means that that point is likely to be maximum or minimum, but doesn't assure us that the point will be maximum or minimum. So if this derivative becomes greater than 0, then we know that the function is increasing. But if the derivative is less than 0, now we will conclude that the function is decreasing. So we'll see more in that in the next video to give continuity to the study of monotony of a function and how to find the maximum and the minimum within a given range.